In this video, we are going to study about dataset and transforms in PyTorch. So there are many datasets that are readily available in the PyTorch framework itself. For example, MNIST, FashionMNIST, ImageNet, and many other datasets. But sometimes you may need to work with your own dataset, and for that you need to create your own custom dataset. So let's see what we will cover in this video. So we will define a dataset class of our own, and we will create an object of it. Then we will define dataset transforms. So first we will see this, and then we will add transform while dataset creation itself. And then finally we will see that we may need to combine different transforms. For example, you may want to randomly crop your images before training. And let's say you may also want to resize them to some particular size. So we will consider them as two different transforms. One will be crop, one will be maybe scaling or resizing. And there can be many more transforms. So you can compose those multiple transforms into one, and then those all transforms will be applied to your data before processing. So let's first create a data set of our own. So in order to create your own custom dataset, you first need to import dataset. So this is abstract class, and it's within torch.utils.data. So you need to import this, and then you will define your own dataset class. So in this case, we will name it my dataset, and you have to inherit from this abstract class dataset. And you need to define these three functions. So one is definitely the init, the constructor, and here you will see that there is a parameter transform. There are many more parameters which I have not written here because we will be covering transform, which is an important parameter here. So its default we have passed to none, so you can ignore it, then no transform will be applied to your data. Then we have get item. So the goal is that this dataset class that you define should act like a kind of iterator. Like a list, like a tuple, or any other iterable in PyTorch. So when you pass get item, and you need to pass an index. So for example, you create a dataset class using this my dataset constructor, and then you can access it with index. So if you pass 1, it will return you the second sample from the dataset. So this index acts as a proxy for this indexing here. And then we should define len, which will return number of data in your dataset. So we will define it in our Google Colab notebook shortly. So first see what is this transform. You can create a dataset without transform also. This is an optional parameter. So in order to define a transform, you need to define two methods within this transform class that you will define. So tra means it's some transform. I am randomly written it a. Then init constructor and call method. So this call method will act as a proxy for this parenthesis. So when you create an instance of your transform, let's say tra equal to tra constructor, and then you call tr this parenthesis, then this method call will be called, and it takes a sample. So sample is one of the data elements, one of the data in the multiple data in your dataset. So let's say you have a dataset where there are two features x1, x2, and there is one output. Let's call it y. So we have 10, 5, and maybe this is 1, then this is 10, 20, this is 2, this is 5, 7, this is 3. So something like this. So this one dataset means this one sample. One sample is one row in this dataset. So it will take this data and apply transform on that. So let's say you want to double everything. So you define your transform in such a way that you double everything, then it will double everything, one of the samples. And before returning the sample, remember that get item returns the sample, data sample, at the provided index. So instead of just returning the sample, it will first apply the transform, whatever transform you define. Then don't worry, we will shortly come to this. We will see example of this, and we will run code in Google Colab notebook. And now next comes that the case where you need multiple transform. You may want to compose them. So for that you will need transforms.compose from Torch Vision, and there you pass the constructor of different transforms that you define. Let's say TRA is first transform, TRB is second transform. So you separate them with comma, just like defining a Python list. So here is the list and these are the transforms. So it will compose that, and you see transform parameter here. So in the first case we will just pass an object of this TRA transform, but once you compose it, this TR composed can be passed here in the transform parameter. Now let's see an example of this to understand. So for our purpose we will define a simple data set. It has just 5 samples, and this is x1, x2 and y is the label, and x1, x2 are the input features, and it has just 5 elements. This is a simple CSV file for demo purpose. So let's open our Colab notebook. We will import torch and this dataset class, and this numpy we will import in order to read the text data, CSV data, and then we need this transforms for transforms.compose. So let's import these dependencies. Now let's create our custom dataset class. So we will call it class my dataset, and it should inherit from dataset class, and then we will define the 3 methods: init, and let's call transform is none initially. So our data is in data underscore 1.csv, these 5 data samples that I just showed. So data we can read using np.load text, and you need to pass the path of the CSV file. Currently it's in the same directory where our script is located, so we are just passing the name of the CSV file. And then the first line, if you see, it's the name of those features and the label field. So we will skip one row. So delimiter in the CSV file is comma, and then skip rows equal to 1. Now this data contains all the samples. Next, let's store the x. So x is in the first and second column, x1, x2. So data, all the rows, sorry, and then in the columns we have to pick 0 and first column, and then it's a numpy array, so we need to convert it to torch array. So from numpy, similarly self dot y equal to torch dot from numpy data, all the rows and just the third column, and then self dot transform is currently none, but let's assign it to self dot transform, and then self dot length will be data dot shape 0, or you can take 0, 1 or 2, anything will work. So our constructor is defined. Next, let's define the get item method. And here it takes one index as the parameter. So return that sample at that given index. So the sample consists of the input features as well as the label. So first we take self.x at that index and separated by self.y at the same index, and if the transform is defined, then apply that transform. So sample equal to self.transform that sample. So currently it will skip these two lines since self.transform will not be defined if we don't pass it. And finally let's define the len method. So we can simply return self.length since we have already calculated in the constructor. So our custom dataset class is defined. Let's create an object of this class. So we will call it ds equal to my data set, and we are not passing any transform. And so what we can do, we can print first 3 samples from this data set, I in range 3 ds I. And also print these values, and let's see what it prints. So it prints 1020 and the y value is 2, then 525 and the value is 1, 27 and the value is 0. So if you look at this CSV file, you will get exactly same values. The first 3 samples are printed. You can also find the length of your data set. So you can call len ds and it should return 5. So now you understood how to create a custom data set. Now let's define a transform. So we will define a class. Let's call it tra and define the init. And let's add for this transform, let's say we are scaling both the input features as well as the label by some value. Let's call it s, and by default the scaling factor is 1, so it will not change anything. But while creating the object of this transform, we can pass some scaling factor. So x equal to here we will simply assign, we are not applying the transform, or we can write a scale equal to s. Next we will define the call method which takes a sample as input and then apply the transform to that. So x is sample 0 and y is at sample 1. So what we can do, we can multiply this with this scaling factor, and the same thing we can do for y self.s and then sample equal to x comma y, and then return the sample. So what it's doing, it's taking the sample as input, it's applying those scaling factors to them and then returning the updated sample. Now let's create an instance of this transform. So tr1 equal to tra, and let's pass a scaling factor of 10 so that we see some difference. And then what we will do, let's create another dataset class, but this time we will pass this transform. So earlier we did not pass anything here. Now we will pass this transform. So the same dataset class, but with transform equal to tr1. And now again the same thing. Let's print the first 3 samples. So we will compare with our earlier result. So you see it's the same, so somehow it's not applying the transform. Let's see what's the problem here. I think we are printing it wrongly. So this should be ds1. So it was printing that earlier ds that we had created without any transform. And let's see. And now it works. So you see it was 1020 and 2. So it becomes 100, 200 and 20. Similarly, all the other samples are also scaled. So this was example of passing just one transform. Now let's define another transform. So let's take the same transform class. We will slightly modify it. Let's name it trb. So in this case, let's skip this init. We will apply some transform directly here. So what we will do, let's apply some random transform. Let's add 10 to all the input features, and then let's multiply the labels by 2. So this is some random transform we have applied just for demo purpose. So our second transform is defined. Now what we will do, we will create a composed transform. So let's name it transform composed, and then transforms.compose, and here we will pass all the transform as a list. So tra, and here we pass a scaling factor of 10, and then trb, which does not take any parameter. We have applied the transform within itself, and now this composed transform can be passed to create the instance of our dataset class. So ds2 is again my dataset, and here we pass transform equal to tr composed, and again the same thing, print the first 3 samples, and then we will compare the difference in outputs. So you see first it applied the transform 1, which multiplies everything, input features as well as label by 10. So this was 1022, so these becomes 100, 200 and 20. Now in the second transform trb, we add 10 to input features. So these are increased by 10. So 100 becomes 110, 200 becomes 210. And in the y, we double it. So it was 20, so it becomes 40. So you see both the transforms are applied and you get a composed transform. So I hope you understood it, how to create a custom dataset, how to create a custom transform, and how to compose different transforms into one. So in the future lesson, we will continue our discussion on datasets in PyTorch.